building on our previous lessons where we explored the functions, usage methods, and steps of general register instructions and position register instructions. Today's lesson will focus on the application of conditional comparison instructions and conditional selection instructions. In industrial robotics, it is often necessary for robots to perform comparison and judgment tasks to determine the next action to execute, ensuring better alignment with production requirements. So, how do industrial robots decide what to do next? The topic of this lesson, application of conditional comparison and conditional selection instructions, provides a clear solution to this question. This lesson will cover 4 key sections. 1. Register conditional comparison instructions. 2. I or O conditional comparison instructions. 3. Logical conditional comparison. 4. Conditional selection instructions. By the end of this lesson, you should be able to 1. Identify the 4 types of conditional comparison and conditional selection instructions. 2. Understand the formats and applications of conditional comparison and conditional selection instructions. Let's start with register conditional comparison instructions. Register conditional comparison instructions compare the value of a register with another value, and if the comparison is valid, specific actions are executed. Here is the format of register comparison instructions. If represents the conditional comparison instruction variables. These can be R, I, or $system variables. Operators include greater than or equal to, less than or equal to, less than, and not equal to. Values, these can be constants or register values, e.g., R, I. When the variable and values satisfy the condition, the program performs the corresponding action, which could involve jumping to a specific label or calling a subroutine. Let's look at an example. From this example, we can see that before using register R1, it is necessary to initialize the register with a specific value. Without assignment, the register might hold an undefined value, leading the program to deviate from its intended operation. In the third line of the program, we add a label as an entry point for when the condition is met. The fifth line increments the register by 1 each time the program executes, effectively counting the number of iterations. If the value of R1 is less than 3, the program jumps to label 1. Otherwise, it proceeds to execute the instructions from line 7 and 8 onward. 2. I or O conditional comparison instructions. I or O conditional comparison instructions compare the value of an I or O signal with another value. If the comparison is valid, the corresponding action is executed. The format is as follows. If represents the conditional comparison instruction variables. These can be AI, I, AO, I, GI, I, or GO. I operators include greater than or equal to, less than or equal to, less than, and not equal to. Values can be constants or register values, e.g., R, I. When a variable is compared with a value, if the comparison is correct, the corresponding action will be performed. This action can involve jumping to the appropriate label or calling another subroutine. For analog I or O or grouped I or O conditional comparison instructions, commands can be written as follows. If AO 1 greater than 100, JMP LBL 1. If GI R 1 equal to 100, call test. For digital I or O conditional comparisons, the operators are limited to equals and not equal to. Examples include: if DI 3 not equal to on, JMP LBL 1. If RO R1 equal to off, call test. Here's an example using comparison instructions. JP1 represents a joint movement, and the second line LBL1 is a label. The third line LP2 is a linear movement instruction. The fourth line contains the instruction if DI1 equals on, JMP LBL1. This means that if the value of DI1 is on, the program will jump to LBL1, and execution will begin from the second line onward. The difference between this example and the previous one we discussed is that we changed the loop condition from a register comparison to comparing I or O signals. If the condition that the value of di, 1, is less than 3 and is on as myth, the program will jump to label 1. If not, it proceeds with instructions from line 7 and 8 onward. Next, let's take a look at logical conditional comparison. Logical operators, and, or, can be used in conditional statements to evaluate multiple conditions on a single line. Therefore, this simplifies program structure and facilitates effective condition evaluation. Here's the format. 1. Logical and. Logical and compares multiple conditions listed after if. Only when condition 1, condition 2, and condition 3 are all true does the program execute the predefined instructions. If any of the conditions is false, the program proceeds to the next instruction. 2. Logical or. Logical or compares multiple conditions listed after if. If condition 1, condition 2, or condition 3 is true, the program executes the predefined instructions. If none of the conditions is true, the program continues to the next instruction. When combining logical operators such as and or, the logic becomes complex, negatively impacting program readability and ease of editing. Therefore, this feature does not allow the combination of and or in a single instruction. In a single instruction line, when teaching multiple and or states, if one is changed from and to or from or to and, all other and or operators will also be replaced with the changed operator. The maximum number of conditions that can be linked using and or in a single line is 5. Finally, let's study conditional selection instructions. Conditional selection instructions allow the program to branch to specify jump instructions or subroutine calls based on the value of a register. Conditional selection instructions are essentially composed of multiple register comparison instructions. They compare the value of a register against a set of predefined values. If the register's value matches one of the predefined values, the corresponding jump instruction or subroutine call is executed. If the value of the register does not match any of the specified values, the program will execute the corresponding jump instruction or subroutine call instruction associated with else, other. In this example, we can observe that if the value of register R1 is 1, the program jumps to the location marked by label 1 for execution. If the value of R1 is 2, the program jumps to the location marked by label 2 for execution. If the value of R1 is 3, the program jumps to the location marked by label 3 for execution. If the value of R1 is anything other than 1, 2, or 3, the program jumps to the subroutine label test for execution. Okay. After completing this lesson, I believe everyone has gained a certain understanding of the application of conditional comparison and conditional selection instructions. Please review the material thoroughly after class to lay a solid foundation for effectively operating industrial robots in future practical work. This concludes today's lesson. Thank you, everyone.